The topics that we cover today is the sensors. I am going to introduce to you guys about sensors. Probably you've never heard of many sensors yet, right? Although it is very, very popular that enables artificial intelligence more intelligent. Devices itself may not be intelligent without sensor deployment. So sensors are really, really important. There are thousands and thousands of sensors available and also still developed. Human has only 5 senses, right? Human may not have GPS sensors. Anybody has a GPS sensors? You know where you are when you are dropped in one spot. Then here I am. Our human sensors are biological sensor, and therefore it functions very well. Our visible sensor through our eyes, usually it works perfectly fine, right? Although depending upon the people, somebody can see more clearly than others.
It works. After 4 years, they fixed the screen for you.
It is not. I'll explain that later if you want. It through the windows. Remember that through the windows it works, right? I don't have any connection from my MacBook right now. All right. So what is a sensor? Sensor that human developed is a device. Sensor that human I think biologically received. That is, there's only 5 sensors, so that we can see, we can touch, and we can smell, we can taste. I think 5 sensors, right? 5 sense that we have. Even taste, that is very, very sensitive and sophisticated if you compare with some other mechanical sensors. But still, the food taste sensors has been developed since many years ago, so that they can the food processing and food production was able to be automatic right now, depending upon some food. Most likely Japanese food can be turned to automatic because there is so clean shot of taste. Anyway, so sensor is a device. It can transfer from one energy type to another energy type. The output energy usually there's electrical energies. So it could be a volt, could be some current, but input could be anything. It can come from temperature, it can come from photons, which means light or dark, can come from food, can come from smells. some mechanical movement also. If you go to hospital, then many cases, if you see a hospital, the medical doctors, then they don't do much, but their diagnosis relies on some devices. That device has all kinds of sensors that monitor your body, sensing your body, and tells you how you are, right? So if the sensors are not developed, then medical doctors cannot do anything further. But I don't say to you that medical doctors are useless. Sometimes you can see the medical doctors, but don't trust the medical doctor 100%. Their diagnosis is something that they can get from the current technologies. So tomorrow's diagnosis may be better than today's diagnosis. It is not true if medical doctor said, "Oh, you are okay, definitely." There is no such things, right? You are okay based on some of the devices that doctor currently uses. So sensors has been called in electrical engineering in different name. It's called the transducer. That name has been more than 5 decades. So typically, electrical engineering teaches transducer that is currently nothing but a sensor. Therefore, transducer can receive a signal. That signal comes from the environment, it comes from your body, comes from anything, right? And then the transducer returns some other signals. The way that we can use the transducers, the outcome is based on, it is definitely by the computer. So computer can read only electrical signals. So we better have to produce electrical signals from transducers. Okay, so below we have 3 bullet points: input energy and output energy in between transducer. Input energies can be acquired from physical, chemical environment. Okay, so it can be a light, sound, heat, pressure, motion, chemical, therefore we can smell. All kinds. That is input energy. Sensor technologies is nothing but the electronic device manufacturing. There are lots of sensors, cheap sensors available from China, but the quality is not really reliable. But if you purchase some sensors from Japan, Germany, and America, then it is really, really expensive. So here in academia environment, we don't use usually that expensive sensors. So very cheap sensors. We simply try to test it. Transducer is a core element in the sensor technologies. So it can convert from input energy to output. So output energy that we can utilize very easily using computer. That is electrical, right? Electrical energies. So I have some sensors here that I brought. Let me show it to you. Where is this? Can you see? Speaker, gallery, multi-speaker. And speaker, why this guy? Instructor's copy. Can you see this? Oh, you can see this. Okay. So let me put, this is a list of the sensors that I purchased. Okay. This sensor was, I purchased this many, many years ago. I think longer than 5 years ago. Right now, a lot cheaper, a lot more sensors possible. At that time, these 37 sensors, the price, I think about $20, $30. Okay. During that time, Raspberry Pi was not really popular. Rather, Arduino, that is another microcontroller that has been so popular. So we used the Arduino. Only the drawback of using Arduino is that Arduino is by default you have to code in C language. But in Raspberry Pi, you can also use C and Python by default. Many good features using Arduino. I mean Raspberry Pi. That's what we do. Okay. So let me pick one of the sensors. I'm going to pass this around so you can touch this. For example, please do not, when you pull out the sensor, then I want you to put it back to the same bin. Otherwise, this will be messed up. So we have this. I have a 37s. So I picked up this from third and fourth. Oh, this is button. Let me pull up something else. Maybe. Okay. Typically, okay, temperature sensor. This is a temperature sensor. This is the temperature sensors. If you see one from somewhere here, let me put this up. So this is a temperature sensor. Then you can see the pins, right? Here are 3 pins. Somewhere it says, oh, it didn't say anything. I believe, yeah, this side sense the pin is for S for signals, right? And then the other side of the pin, there is a minus sign, so that is a negative. And in the middle, therefore, that is, I think, plus sign, and this is a signal. So you can get the temperature signals from here. I wanted to recall the Raspberry Pi has the 40 pins. So you need to plug the properly minus that goes to ground and plus sign, then you need to receive the power. Could be 5 volts or 3.5 volts. Usually 5 volts is enough. And then signal, this signal is the pin that you can read the data. Okay, so each device sensor, your coding should rely on the manufacturer specifications. You cannot do anything without knowing the specifications of that sensors, because a pin needs to be properly linked, and your code needs to take the data from that designated pin numbers. So all such things are very, very sensitive and should be accurate. Otherwise, you don't get any data. So, so as you could see here, the pins, some sensor has 3 pins, some sensor has 4 pins, 5 pins. The image sensors has a lot more pins. For example, camera sensors. So I'm going to pass this around so you can take a look and get some idea. So one of the sensor is missing, if you can see it. So one empty bin there. It is for laser emitter. Laser signals can be emitted from that device. I probably used that for some other experiments. So what you can do with that device, you can send the laser signals with the data that you want to send out. Okay, that is a wireless communication over the laser signals. And the other side, you should have a receiver, laser receiver, or if you tune the frequency properly, then LED light receiver may be able to receive laser signals as well. That's what I think I tested many years ago. Okay, with that, now we'll look at the list of sensors. Therefore, you may feel some idea what you want to do, what you would like to do. So sensors can be grouped in many ways, but on this slide, we have about 10 different groups. It may not be exact 10, 2, 4, 8 groups. Environmental sensors, motion and position sensors, proximity and distance sensors. So how close that object is available from that sensor device. That is what this is. Health monitoring sensors. This is a very, very popular. And if you can work on this health monitoring sensors, then you can make big money, right? So medical, usually diagnosis and treatment is so expensive, although sensors are not really expensive. If you use cheap sensors, of course, then you may not get the accurate diagnosis. But anyway, that is all possible. And sound and vibration sensor, optical and imaging sensors. Again, imaging is is very, very popular in health, right? So all kinds of surgical treatment or procedural treatment in medical environment relies on the cameras, right? If they the traditionally without open our organs, the medical doctor may not be able to do anything. But these days, they open small port from your body, and through that port, usually they push the cameras, push some medical devices to treat. So camera is very, very important in the case, right? So that is imaging sensors. Electrical and current sensor and other specialized sensors available. So more specifically, if it is environmental sensors, then we have temperature sensors. Temperature and humidity. In this first model, THT11/, this is one type of the sensor, and little advanced ones is the THT22. These sensors, this is the sensor models. There's a temperature and humidity sensors. If you click this, then you can see the particular. You can find out the similar sensors. This most of the website, if you are lucky to find out some sensor that you want, together with the coding list. So in this case also, there's some prerequisites, some of the sensor explanations, wirings. See here how you can wire. This is the Raspberry Pi, and we call this breadboard. You may need or may not. Breadboard is very, very handy in order to joint two jumper cables. Rather than yield them, you can simply plug it into this breadboard. So breadboard looks like this. There are a little bit different shapes, different size. But at one end that you can see here, this is the power plus sign and negative sign. This breadboard, the holes, through vertically, they are all connected internally. So if you plug here, for example, and plug another, that means they are connected. Okay, vertically here, the power lines are vertically connected. On the other hand, there are other inside. There are other holes available. This is horizontally connected. Okay, therefore, this is a temperature HDT22 or HDT11. We'll look at this actually later. This guy has 4 pins, right? So 4 pins here. Probably this 30 pins not used, but 3 pins. You plugged here, which means this pin is connected to red line here. That is nothing but power lines. I believe this is maybe 5 volts. So this pin receives 5 volts. And another pin here, the very next, you plug it here. So horizontally they are connected. So this pin is connected to directly here somewhere. Maybe through this, this is called the GPIO number 4. So through this your code in this Raspberry Pi wants to read the data. So this pin can give you the data. So you need to read. Your program needs to read. When you read this data, then you need to say, hey, GPR number 4, there is a data pin. And then in your programmings, you can say if data pin is greater than 5, then that is whatever means the 5, right? So it connected to this blue line. Through this data can be acquired, and then that is also connected to this resistance. This resistance connected to the power lines. I think this is somewhat, this goes to here. So one blue line and this one maybe next to this. Therefore, this third pin, no. First pin receives the power here. Oh, here. The last pin that receives the ground. So this is a ground pin here. Okay, there's 2 pins left. So one data. And also, usually when we use resistance, so resistance stabilize the signals. If any data at certain points is surgical, it goes up through the roof, whatever that tolerance levels, then this resistance can press it down. Therefore, it comes from the input, the power lines. So if power line is not stable, then through this surgical resistance, it can stabilize that. I'm not sure this is accurate, but this is the kind of things that you can get from that website. So all the way up, then, and the other one here, this is wiring. And the last bullet points here, Raspberry Pi getting temperature and humidity through Python script. So if you click this, then Python script. So import time and board, that is, Raspberry Pi has 2 different modes to wire. Raspberry Pi has 40 pins. When you connect from a pin to your sensor device, 2 different modes available. If you say here board, then that is the mode that your program wants to rely on, that serial way of wiring mechanisms. And on the other hand, there is another way that you can do it. There's a BCMI mode. The exact same thing can be wired. Exact same sensors can be wired differently depending upon the wiring mode. In this case, this guy wants to see the board mode. And then this is come from the manufacturer. So Adafruit is a company. This is a very good company. I like all the sensors produced by this company, Adafruit, and then DHT. Originally, this is an American company, but right now I think it is actually manufactured in China. Therefore, it is cheap, but quality may be controlled. Anyway, so some of the configuration here, and then we have a while loop. So sensor, the functionality of a sensor, the beauty of a sensor is that once you set up the sensor, then that device continually function to do the work as designed. It's not like humans, right? Humans, if you say your friend, hey, watch over this, then your friend may watch it, but not continually, not 24/7. But sensor device can do, as far as power is continually supplied, then sensor works. So this is some of the codes. So we'll explain that later, not today. Okay. All other things that you can find. All right. So this is one example that I pointed to you here. This, if you are interested in this sensor, then you can get that here. The other sensor is a temperature and pressure sensor, BMP 180, BMP 280. Let's together to find out. Okay, so BMP 180. So BMP digital pressure sensor. This comes from also Adafruit Industries. This is a PDF files, or maybe this is a static documents, right? This is website. Okay. So this is a BMP 180, barometric pressure and also temperature. This kind of sensor is widely used in airplanes, right? In airplanes, temperature needs to be maintained well, and also pressure. Air pressure needs to be checked all the time. Otherwise, your flight may be crashed, right? Unfortunately, the last few months in Korea, 2 airplane crashes. Unfortunately, sad story. But anyway, that may happen if they don't use accurate sensors. Okay, pilot cockpit. The pilots usually look at their displays, right? There is a pilot end, but at the other end, there is a sensor device connected. If they used very cheap sensors, the sensor may not detect proper, accurate data. Therefore, pilot may misunderstand, and that leads to disaster. But anyway, this is a BMP 180 pressure sensor. Look at this. This case, 5 pins available, right? So this SDA data, SCL data, GND, this is ground. This is power, 3 volt. This is power line and then ground lines. And the other one is VIN, and this is another power lines. So in this case, SDA and SCL signals needs to be captured. Then on your Raspberry Pi has what it does here. This can be communicated through the wireless. Wireless communication is possible. Okay, so depending upon the antenna that your Raspberry Pi use, there are actually 3 kinds of antennas that can transmit the data. Okay, so one type of antenna rely on this kind of signals. Okay, not sure. Yeah, I will cover that different types of the antenna, and therefore we can receive the data from that specific sensors. That is the case here, right? So this is one example. Humidity can be monitored also. The exact same one that we looked at can be used. Or pressure sensor, similarly, PMP 180, 280. And the gas sensor, MQ series gas sensor, this is a popular. So if your home has the gas supplies, then let's say if there is LPG gas, okay, liquid, there's a natural gas, right? Or propane gas. There are all different kinds of gas available. So gas smells can be detected by gas sensor. So MQ2, MQ3, MQ7 sensors, I've used this a couple of times. The quality is not really good, so I was not successfully checked the gas. So I tried that at home. I turned my gas oven, tried to test that sensor, but didn't check. Maybe CCS 800 air quality sensor. This may be okay. So if you want to see MQ7, for example, then you can also here MQ7 sensor. So there's some videos available, right? Usually gas quality or air quality or gas detections, the idea is this. The device has a small area, so if that chemical components comes in that area, then usually that sensor calculate the density of some of the particles that is not normally admitted. If some unknown particle comes in that limited space, then they calculate that particles. Okay, so they set some threshold. If that number of particles over that threshold, then this sensor say, hey, we have gas leakings. Hey, we have the bad quality of airs. That type of things can be detected. There is a gas. Light sensors. This is the LiDAR, LDR. No, light dependent resistance. This is not, okay. So the other is ambient light sensors. So you can find out some of the specifications. Okay. Soil sensors. If you are running a smart farming, then you can set up soil sensors so you can capture soil moisture sensors, and also, yeah, this is similar things, resistive and capacitive. So moisture can be measured by this sensor. A lot more than this. Okay. And then motion and position sensors. Accelerometer, that is also popular. Your cell phone has an accelerometer sensors already built in. Therefore, for example, gyroscope, if you move your sensors like tilt, then it reacts as you moves, right? That is called accelerometer, or gyroscope is usually see the balance, okay? How it is tilt. Accelerometer is how quickly it moves to you. If you yeah, that is that is also similar to proximity sensors. How close they are, proximity. Accelerometer is how quickly they are approaching to you. Gyroscope is how they are balanced. For example, in our ears has a gyroscope. If somebody has boat sick, then your gyroscope works so sensitively. Somebody do not feel much when you sail over the oceans, which means your gyroscopic sensor is not really sensitive. Okay, what is your case now?
I'm
Are you
in
good
the
at
middle. I'm in the middle. I can take a boat trip, but too much, too long or too rocky, I get sick too.
you're not really sick?
Yeah, I don't
Over the
really
ocean,
get
yeah.
like if it's
Which
not too
means-
rocky,
yeah.
and I can.
Which
stay.
means your gyroscopy is not really sensitive.
Yeah.
My gyroscope is really, really sensitive, so I cannot sit on a boat when, yeah. Magnetometers, how they are magnetics. IMU, inertial measurement unit sensors. IMU sensors also embedded in your smartphones. Motion detector, they're so popular at home, right? PIR, P stands for passive, A stands for active. PIR, then there's a passive IR motion detector. IR stands for infrared. The frequency of infrared is the frequency a little lower than red visible frequencies. Human, we can see some of the light frequencies from red to purple, right? The frequency of a red color is a lower frequency. Frequency of a purple, violet color is high frequency. Above that violet color, we call that ultraviolet frequency. Below the red color, I'm talking about red light color, not the red paint color. Red light color, that is called infrared. That's a little lower than red light. The frequency of our smartphone is a lot lower frequency than the red color. Frequency of our Wi-Fi signals is a lot lower than sunlight frequency. Depending upon the frequency, it has a different energy. High frequency has a higher energy. So our sunlight carries a lot higher than our cell phone energies. So somehow cell phone signals is a lot safer than sunlight. A lot higher than sunlight energy is X-ray. X-ray has very strong energy. So if X-ray touches human bodies, then our human cell will be dead, right? Therefore, X-ray is not, our body should not exposed to X-ray often. I'm now explaining to you whole spectrum of frequencies, okay? Because you guys are not really in engineering side, but that is common sense these days. For computer scientists, without knowing engineering concept, your development may be limited, maybe 50% only. Why? Because the world right now here is a cyber physical world. Physical plant can be operated by cyber specifications. So motion detector is really, really popular. Motion can be detected by sending out the signal first. So your device should emit the signals. The frequency of that signal is infrared frequencies. That infrared frequencies is a lot dangerous than your smartphone signals. But if we see in our nature, our sunlight is not. We don't see sunlight is really harmful to human, right? But sometimes it is, but not usually in daily life. So lower than that, because the red frequency is below. We call that infrared. So that device, that sensor uses infrared signals to emit. So that signals goes out, and when there is an object, then that signals can be reflected from that. I think I need to draw here rather than see here. We'll look at that in physics. In next week, another sessions. Today, I'm going to introduce to you only the kinds of answers so that you may get some ideas, right? Let's say here we have IR, infrared sensor. But if it is a P, then that is a passive. Therefore, this guy sends out signals. We have objects here. Then there is a reflect. Okay. So they check the time here, and check the time to emit, check the time to receive. There's some time elapse, and therefore we may be able to see if that object is moving or not, right? If this is a static wall, your motion detector does not detect a static wall, right? Only detect if there is some moving objects by measuring the time, and therefore we can see the distance. Passive means object does not give signals first. Only this device first send out the signals and receive the signals. So two signals needs to be considered. All the initiation needs to be done by this device. Then there is a passive. Passive means signal means passive. If we say active, then this object generates the signals first. For example, temperature. During COVID-19 period, if you go to some building, then they check your temperature, right? As they check the temperature, they never touch you. How do they receive your temperature? If you pass through the airports, then there's some sensors, right? Human body, our human, if body is alive, then we have some fever, right? Some temperature. Temperature is emitted from our body. So that sensor only receives that temperature signals. Doesn't need to send out, and does not need to rely on reflected signals. Because human body, anyway, send out the temperature signals. So receive that signals and make some decisions. That is active sensors. Sensor is not itself active. I don't know why they name that way. If we say PIR, then sensor may be passive. But actually sensor actively first initiate. But anyway, they defined it that way. So don't be confused. Active and passive. Proximity and distance sensors. Ultrasonic. Now we have ultra, right? Ultra means infra means little lower. Ultra means little above. Okay? Sonic means, these are sonic signals. Sonic means sound, acoustic. Our acoustic, the frequency, acoustic, hearable frequency range is from 2 hertz to, I think, 20 kilohertz. Only if some sound vibrated 20,000 per second or 2 times per second, in that range, then we can hear, right? Any above that, we cannot hear. So hearable frequency range of human is not the same as other animals. For example, doggies. Doggies can hear some sound which human cannot hear. You know that, right? On the other hand, if you have a hen cannot even hear something that our human can hear. So if you shout to chicken may not hear if you shout so high frequencies. I didn't test it to chicken because I do not have chickens, hens. But if you have, you can try. If you shout loudly to hen, then hen usually do not care. Don't beat him. It's natural. Okay, because different range of hearable frequencies. So sonic means that frequency. So very, very low frequencies. So little above that, there's ultrasonics. So ultrasonic has been used in medical medical communities so much, right? Ultrasonic test. So if you have some issues on muscles, then usually they use ultrasonic sensor device to check if your muscle functions well. Infrared sensors. This is a little lower than red color signals, red light signals. Sonic means sound signals. Okay. LiDAR. LiDAR sensor is very expensive if you compare with other sensors. For example, ultrasonic sensors. HEC SR05. Let me bring that here. HEC SR05. This is an ultrasonic distance sensor. Amazon. Let's find out how much do they charge. $9. This. Price went up too big. About 5 or longer ago, this about $1. I don't know. But anyway, But if you go to other website, then you may be able to see some more. Well, this is a $7 cheaper. Then you can see. Sometimes you can get the Python code. Sometimes you may not. If you see here, this has 4 pins, right? Let me get another. Amazon ones can see the magnitude. Oh, this does not have this pins. Why does not have pins? Oh, because of Val, I want to see only this, not that particular vendor. In general, okay, then you will have here. In general, CO2 sensors, $7. 5 sensors, $10. So if you click this, then you can see here. Can you see that the magnified the images? So left VCC, trigger, echo. On the right end, there's a ground. So left side, you can receive power. On the right side, there's a ground. There are 2 more pins in between, trigger and echo. So when you check this, this is a distance sensor, right? You can check only the distance from the ultrasonic sensor. See, there are two outlets, right? So one outlet maybe trigger the signals, the other outlets receive the signals. So sending out, so one signal here send out, and another outlet here, inlet, receive the signals. So some computation in between, and therefore measure the distance. Okay, that is what they do. But LiDAR is very, very expensive ones. Because this is expensive, as far as I know, the older version of Tesla does not equip LiDAR distance sensors.
It used to, but not anymore. No.
What?
When they started, they did, but then
They
they
did?
decided it was better to just use what they use now.
I don't know.
Yeah.
But at one time, when I asked, they said, "Oh, we don't use a LiDAR."
Yeah.
So LiDAR is a very, very powerful distance sensors. It uses a laser. L stands for laser. So laser signals, the strength of a laser signal is that it points. It is very powerful. Number one. Number two, it may be drawback or maybe strength. It can touch the point, accurate point. It does not touch the area. There is a laser. To overcome that drawback, LiDAR try to see the area. LiDAR stands for somewhere here, area. So there is a mapping and navigations. Some of the areas, maybe what they do is that they're scanning. They send out the laser signals, so many laser signals. So covering that areas. So by rotating, so sensor has some motors there, so that motors are spinning. As the motor spins, it sends out the laser signals. So that is called the LiDAR. LiDAR has been used by highway patrol, police, they use the LiDAR to check the speed. So usually what they do is that they have a speed gun. So when they check the driver's speed, they usually like point to the vehicle, try to get it accurately. The reason for that is because there is a laser signal based, which means they need to point accurately. Then they get the accurate data from there. So that is a LiDAR. Health monitoring sensors. A lot more than that. There's a KGB sensors, our cardio, our this is a heartbeat. Heartbeat can be measured. Oximeter, our oxygen levels, blood oxygen levels can be measured. Let's try to find out this, how much it is. Max 3102. Max 3102. Data is an analog device. So $5 for two. Very cheap, right? But if you go to hospital, I think they charge big money to check your blood oxygens or heart rate measures, temperature also. So a lot more sensors have been developed for health purpose. Okay, so a lot more. So many different kinds of health-related sensors have been developed, and sound and vibration sensors, microphone, of course. How can it detect some noise? Usually we receive the sound through microphones. So basic sound detections, KY038 or 12S MEMS microphones. This is high quality. So sound detection is another big issue in security, right? When something happens, then there is always a sound takes place. Okay. So let's see. I'm not sure this is 12 or I2S. Probably I2S MEMS. So I want to check I2S MEMS. I2S MEMS. Adafruit I2S MEMS microphone breakout. Oh, this is a good. Usually, okay. So we have six pins to be used. Only $6, right? So you better have these pins, and then therefore some of the sound can be detected. This is a Raspberry Pi. You may use this kind of shield, but not necessarily. You can use this. Technical details. Right. So we have pin specifications. So voltage is ground, BCLK. I'm not sure. This is not any defined topologies. This is something defined by this company. I do not know this. So read that specification, then you can see what it is. So digital MEMS microphone madness. Let's see, what is this? Yeah.
So we're learning about many types of sensors here. I'm also just thinking in terms of the final project for the class. How many sensors do you expect us to use? Can we just pick one kind?
Yeah, one kind.
Pick a kind. And
But
use it.
if it is a simple temperature sensors, not much meaningful, right? But I want to get something that you want to practice. Okay. Something meaningful that you can interpret. But one or more, not really any restrictions. Vibration sensor, this can generate the signal, the sounds. Camera is really big issues, right? Raspberry Pi camera is a little higher quality. Usually it is about $50, but I'm not sure how much it is right now. So RGB color sensors. So camera, I think I have another slide that I can explain to you more. Voltage, current sensors, energy monitors, all different kinds of sensors. Others, rain sensors, you can check rain. Touch, this is also popular. When you touch, then you can using the capacity, you can check. Others is RFID, NFC sensor. This is very, very popular these days. All the IDs, if it is not magnetic. Your Mercy University student ID is is it magnetic? No, that is I think it's an RFID card, right?
Yeah, for the door in the front.
Yeah, there's a RFID card. So RF stands for radio frequency identifier. So RFID has RFID signal generator and RFID signal reader, two different devices needed. But RFID signal, if you want to check RFID signal in longer distance, then both two devices, reader and sender device, needs to have the power. But other than that, if it is a short distance or touch almost, then card does not have a power, but reader only has the power to read. So RC522, that is our RFID reader. This is pH number and conductivity sensors. If you are running a smart farming, then you may need this pH sensor. Something more about camera. Raspberry Pi has cameras, Model 3 to, yeah, it's manufactured by Sony. 12 megapixel images can be generated by this autofocus, high definitions, wide range lens. It's very, very powerful. So interface, CSI interface connectors. So Raspberry Pi has a CSI interface, the pin outlets, right? You can plug that into. Source code widely available for this. So you can simply download the source code. You can take photo very easily. But on using your Raspberry Pi, if you want to, this camera itself by default take still images only, not the moving images. So what you need to do, using your using your Python code, you can take the still images frequently. Then you can emulate. It could be a moving the pictures. You can try that. I tried a couple of times for this. For example, therefore, if you are interested in camera, then you can build that camera on your Raspberry Pi, and the images can be sent to the cloud server that I prepared. That is a real sophisticated project. Not only that, you can the camera can be started manually, but it can be activated by sensing using some other sensors. For example, if there is some motion can be, if motion is detected, then there is a time that your camera start taking photos and send that to the cloud server. That type of device is commercialized, right?
Ring camera.
So,
Amazon Ring camera.
right. Specialized cameras. So the others, typical again, the image cameras. Other specialized camera, thermal cameras. FLIR Lepton modules. So I use this. This is when I purchased this long time ago, they charged $300, but the quality is not really good, and then the accuracy is not really high. Although it takes human images, and human images rendering by the temperatures. So if I take your photos using that cameras, then it doesn't take your the face images. It takes the temperatures. So usually high temperatures can be visualized in red. If it is, then human head usually very, very red, and your hand is blue, which means cold. So depending upon the temperatures, you can visualize it. That is possible to have this. If you are interested in this kind of thermal cameras, you can try with this. This is really high selling. Okay. And also this thermal camera has been used to detect the airport gate usually. So if somebody has high fever during COVID-19, they check, they single out that objects very quickly. So that time they use these thermal cameras. This is good too. And then time of flight cameras measure distance using light pulse. Camera can check the distance stereo vision camera. This is another. It's not simple vision, but stereo visions. I've never used this. Light vision. Oh, I checked this a lot. Night visions. So without light, your camera can receive the images, right? Receive signals, receive image signals. Ironically, the camera industries, when they first make a lens, they filter out black light, black signals. Black signals? I would say signals with no lights, okay? That is a dark. So what they do in typical the camera lens, they filter out that dark signals, but receives only light signals, bright signals only. Therefore, our image can become bright and clear. The more brighter, more clear, then we may see, oh, this is a better camera lens. So we pay more dollars when we purchase. To do that, they use a lot more filters, okay? So typically the lens itself, with no filter, then it receives any kind of signals, dark signal, light signals, anything. Guess what? Therefore, light vision cameras, if you use typical commercial cameras, then you cannot take any photo in dark room at all, right? If there is no lights, then you cannot take photo at all, because there is no lights, your camera does not receive any signals. However, if you remove all such filters manually, then your camera is nothing but night vision signals. Your camera will become very, very expensive cameras. It is very ironic. If they put more filters, little less expensive. If there's no filters, expensive. Okay? So it is very interesting that I tried with that. This is something that I can share. Okay, this is the last slide that I can share with you. So using any kinds of the sensors, you can wire with the pins, and in your Python identifies that pin. You need to define that pin. I want to use that pin. I want to read the data from that pins. That is something that you can measure. That is the sensor data. As the sensor data is available, your Python needs to send out the signal to the cloud. The sending out the signals to cloud in Python, I will let you know. I'll give you the source code so you may be able to send out. Okay? This is one end of your project. The other end, that is smartphones. That comes in the second phase of this semester. So we are in the first phase. First phase of this semester is very short. Maybe we meet 2 or 3 more weeks covering these sensors, and then the rest will cover iPhone apps developments. Okay.
Hi. So within the first phase, we should look to be able to work with a sensor and the Raspberry Pi to send data to the cloud.
Yeah,
We should
we'll
look to
do.
be able
Yeah,
to
we'll do that. All.
Okay.
Yeah.
Python.
Python.
mostly?
Yeah.
Yeah.
Python code.
Cool.
Any question? So review the slides. Which project that you want to plan? Okay. I want you to make some meaningful plans. So maybe I will post project proposal due maybe in 2 weeks. I will write up in next couple of days and post it. So you guys need to plan what you need to do for your the semester project. So during that time, you need to pick sensor. You need to see some story tellings. So what story are you going to design in your project in that space? Okay, look at that slide. Okay.
Can it be the other way around where I get the data
I know.
and then for example
can do
the
that, right.
the LED light, I can display certain
You know
colors
that?
based on data.
You want to do that? That's possible too.
One of the I like stocks, so you can do the red and
Right.
Yeah,
You need to
but-
put here the actuator, rather than sensor, but
Yeah.
actuator here,
Yeah. It could
and
be
then
fun.
you can start actuating
Yeah.
by clicking some of this. Then it goes.
Might be cool. Just
Yeah,
thinking,
you can-
just thinking.
Propose. If you propose, then I can let you know this is feasible. If it is feasible, how much it would be interesting, or sometimes it may not be feasible within one semester
Yeah.
because you have to prepare a lot more. Usually, actuation, as I said, you first start the motor, and therefore motor can be converted to another movements.
Wow.
Usually. So what are the actions that you can think?
Well, I'm just thinking.
What kind of actions?
For red, like changing the color of the LED lights.
Oh,
Maybe-
light.
Yeah, and then
Oh,
maybe
then you don't need.
Yeah, then it's simpler. It's just
It's
about
not really
getting
motions.
the data and trying to turn that into the logic of changing the lights, right?
You can do that too.
Yeah,
Yeah.
I mean, I think it's feasible.
LED lighting is also using multiple LED lights so that you can
Display
you can
certain information.
you can draw some shapes. Not only one LED lights. You can draw
Yeah.
some letters, like OK sign, or no sign, something like that. Yeah. So the other way possible. Yeah, from your sensor to Raspberry Pi, that is possible. But typically this way, this is easier. You have to make a good scenario to make this reverse ways. So it should be some reasonable. How can you? What is the point that you can turn the LED lights through the Raspberry Pi? What this iPhone apps can do? Only switch. There's
yeah,
there's a
true.
too
Yeah. As to-
too small. But if you could do something little more meaning, then yeah, that's another good project.